Well, here we are again. We're looking at some models that were made out of magnets here. The old Res Dog was on his game when he made this thing. This is sort of like a coral or something. This was trying to figure out how many different ways can you store information on a surface, and whether the surface itself really makes a difference. You know, this one here is all about geometric memory. The fact that that little triangle can remember all sorts of things to do that always end up being sort of fractal. This one here is one of my faves. This is made out of BBs. This one here is made out of BBs. It's made out of bucky balls. There's probably hundreds of them in here. It's completely hollow, and it's 1 BB thick. This is like a cell membrane. And the cell membrane is self-organizing as well. All those little points are actually pentagonal points. Those are like to make a dodecahedron. This that I'm holding in my hand has 12 of those pentagonal points, which qualifies it as being a dodecahedron. Now, if I lift this thing up and I look through it, I'll be able to look through one of the holes that I left to show you that it really doesn't even have to be an integral piece. You can take parts out, make a little ring like this one here, and it still holds its shape. Now, bear in mind, this thing weighs probably 3 or 4 pounds, maybe 5 pounds, because it's made out of steel. And that pattern that you see on the inside is the way that these little things go together on the outside. The pattern is just to sort of imitate an automata, to see what sort of information you can encode on this surface. And in there you can see the pattern of the geometric pattern of the arrangement of the close packed spheres, both as a nuclear bond and as a strong bond. One is a 60-degree bond that you make the parts out of, the pentagons, the plexagons, and the hexagons. The other is the 90-degree bond that bonds those hexagons and plexagons together. This little beauty here, as we switch from vertical to horizontal, sort of a cinematic thing, I guess. I'm not too sure. We're going to climb this thing. We're going to climb to the top, and we're going to look around. This is all made out of hinges, but this shows you that it's a load-bearing envelope. This is a triply periodic, minimal surface, load-bearing envelope. It's